Hello everyone and welcome to this video in which we will learn about time complexity of a computer program. So let's get started. You will agree that sometimes there are more than one way to solve a problem. We need to learn how to compare the performance of different algorithms and choose the best one to solve a particular problem. While analyzing an algorithm, we mostly consider time complexity. Time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as a function of the length of the input. Let me take an example and explain this more clearly. Ramesh and Suresh have been given a common task of finding a number x in a sorted array for various input sizes of the array. However, both decide to use a different method. Ramesh uses the linear search method to find the number and Suresh uses the binary search method. How do we find out which one is better? One naive way of doing this is implement both the algorithms and run the two programs on your computer for different inputs and see which one takes less time. So this is the linear search code written by Ramesh and this is the binary search code written by Suresh. Let us execute the linear search code by calling the linear search function from the main method. For this very large input, we got the execution time as 2.676 millisecond. And now let us execute the binary search code for the same input. As you can see, we got the execution time as 0.065 millisecond, which is quite less compared to Ramesh. Hence, clearly Suresh solved the problem using a better approach than Ramesh. There are many problems with this approach for analysis of algorithms. First of all, it might be possible that for some inputs, the first algorithm performs better than the second, and for some other inputs, the second performs better. It might also be possible that for some input, the binary search algorithm perform better on one machine and the linear search perform better on some other machine for some other inputs. Asymptotic analysis is the big idea that handles these issues in analyzing algorithms. In asymptotic analysis, we evaluate the performance of an algorithm in terms of input size. We don't measure the actual running time. We calculate how does the time taken by an algorithm increases with the input size. Order of growth is how the time of execution depends on the length of the input. Let us take the linear search example. If we draw a graph with array size on the x-axis and the execution time on the y-axis for various input sizes of the array, we will get a linear graph for the linear search algorithm. And for the binary search, we will get a logarithmic graph. Order of growth helps us to compute the running time with ease. We ignore the lower order terms since the low order terms are relatively insignificant for larger input. A program's running time depends upon various factors such as whether it is a single or a multiprocessor machine, what is the read or write speed to memory, and whether you are in a 32-bit or a 64-bit architecture, and of course the input size. However, when we talk about asymptotic analysis, we only consider the input size while computing the running time. So let's say you have this linear running algorithm on a slow machine and we run the same algorithm on a faster machine. Obviously, the time taken to run the algorithm on the faster machine will be much better, but on this graph, both of them are a straight line, which means both of them denotes a linear running algorithm. We use different notation in asymptotic analysis, which we will be discussing in the next video. That's all for this video. Thank you for watching.